Section 7-3 is on solving equations using quadratic techniques. For numbers 11 and 12, we have to write each equation in quadratic form, if possible. So the leading coefficient stays on the outside, and you're trying to write it as something to the second power, plus 6 times something to the second power minus 10. If I write x squared to the second power, we do get 2x to the fourth. The x squared I keep inside of there, and we do get 6x squared, and you are done. On number 12, again, we have to write it as something squared to the second power plus something times 10 times something minus 16. I would need to put an a to the fourth inside of the parentheses to give me a to the eighth. If I write a to the fourth here, that does not give me 10a squared. That is not equal. So it is not possible to write number 12 in quadratic form. Number 17 and 20 ask us to solve. Whenever you're asked to solve, you should pull out your greatest common factor first, which in this case is an m squared. You are left with m squared plus 7m plus 12. What's inside of the parentheses is a quadratic, so you are able to factor immediately. M squared is derived from m times m. The factors of 12 that add up to 7 are 4 and 3. And to get a positive 7, both signs must be positive. Set each of the factors equal to 0 and solve. The first one gives us m equals 0. That's one of our answers. Subtract 4 from both sides and you get m equaling negative 4. That is one of our answers. The last one, subtract 3 and you get m equals negative 3. And you are done with number 17. For number 20, again, we should look for our greatest common factor, which is t. Take the t out, and you're left with t to the fourth power minus 256 equals 0. T to the fourth is a perfect square, and so is 256. So you are able to break this up into two binomials. The square root of t to the fourth is t squared, so that goes in the first spot. Whenever you have difference of perfect squares, one sign will be plus, one will be minus. The square root of 256 is 16. Since our last factor, t squared minus 16, is again a difference of perfect squares, we can factor that further. So we have t squared plus 16, and then t squared minus 16 gets factored into t and t. One is plus, one is minus. The square root of 16 is 4. Set each of the factors equal to 0, and you get t equaling 0 is one of your solutions. T squared plus 16 equals 0, so t squared equals negative 16. When you take the square root, you are going to get two answers. It's plus or minus. The square root of negative 16, remember, is I times the square root of 16, which is the same as plus or minus 4i. T plus 4 set equal to 0 gives us t equaling negative 4. T minus 4 set equal to 0 gives us t equals positive 4. And our fifth degree polynomial has 5 zeros. 2 of them are imaginary, the other 3 are real.